Okay, lesson 1 for this week is how to use trig to find missing angle measurements. Voila. And I'm probably going to have to do 2 videos because I like to talk a lot, you know that. But minimum amount of information required to do this. First of all, you have to know, or you have to be dealing with right triangles. It does not work for non-right triangles. And second thing, you have to know at least 2 of the sides. 2 of the sides. Must know at least 2 sides. And then you can use trig to find the measure of the angle. Steps, 3 steps. First step is figure out if it's a sine, cosine, or tangent equation. And step 2 is set up the equation. Step 3 is solve the equation using inverse trig functions. And so here we go. First problem. The angle we're trying to find is right here. It is clearly a small angle. Find my protractor. So we know that it's 90. This is pretty small. If I had to estimate, I would say about 20. And by the way, you should always estimate before you even begin a problem. That way you know if the answer you get on your calculator is even reasonable. But 20. So if your calculator says something like 100, not reasonable. Keep that in mind. So protractor, put this point right here on the vertex of the angle that you're trying to figure out. And then make sure it lines up on this side. And extend the side of the triangle. And it looks like about 23 degrees, which, great estimate. However, the directions say round to the nearest 10th place, so we're going to need to use algebra to get that detail of an answer. So let's figure out what type of equation we need, sine, cosine, or tangent. So here's the angle that we're trying to find. The side across from it is called the opposite side. The side across from the right angle is the hypotenuse, always. And so we are given the opposite side and this must be the adjacent side. Adjacent. Voila. Now of the 3 trig ratios, sine is opposite over hypotenuse. We know opposite, but we don't know hypotenuse. That one's out. Cosine is adjacent over hypotenuse. We know the adjacent side, but not the hypotenuse, so this one's out. And therefore, process of elimination, it must be a tangent problem. So tangent is opposite over adjacent. We know the opposite side, we know the adjacent side, therefore we can use tangent to figure out the measure of that angle. So tangent of theta equals a fraction. That fraction is the opposite side over the adjacent side, 5/12. If you accidentally do it upside down, you'll know when you try to use a calculator because it'll say error, most likely, or it'll give you an unreasonable answer. And now you have to take the inverse of both sides. That's how you say it. Let me show you how to write it. So again, the goal is to get the variable by itself of any equation. And so we have to undo this tangent function, you have to take the inverse of both sides. So here's how you write it. Now I'll do a little bit of explaining. So that's how you write it. if you're going to show it, that's exactly how I want you to show it. How you say it? Inverse tangent. Inverse tangent. It looks like to the negative 1 power, but it definitely does not mean to the negative 1 power. You'll learn later, maybe this year, maybe in pre-calculus, how you write something to the negative 1 power, how you write a trig function to the negative 1 power. Okay, so this is the inverse function of this function, therefore they cancel, and you get the variable by itself. So theta is equal to the inverse tangent of 5/12. Let me say it again. Theta equals the inverse tangent of 5/12. That's how you say it. That's how you write it. This is the exact answer, by the way. A lot of times on standardized tests, you don't even get to use the calculator. So it'll be like a multiple choice situation. They'll say, what is the measure of that angle? A, B, C, D. One of the choices will say that. They might even have sine as a choice. They might have tangent, but put it upside down to throw you off, etc. Oops, you can't see a thing I'm writing. Sorry. So anyways, a lot of times on standardized tests you don't get to use a calculator, and this is as far as you can go. But on this assignment, we want you to go farther. Let me show you how to do this on your cell phone calculator. It's Mr. McWright's birthday today, by the way. And go to calculator. Let me show you how to get there. So, all smartphones have a scientific calculator. You just have to figure out how to get there. For mine, I go to calculator, then I swipe left like that. So this button right here, INV, stands for inverse. So right now you have sine, regular sine, cosine, and tangent. If you want to do the inverse of those, you hit the inverse button. And by the way, I probably might end up saying this a few times today. Inverse. The purpose of an inverse tangent or inverse trig function is to find an angle. Period. That is basically the only reason why inverse exists. So inverse is to find an angle. And now let's do it. So you go inverse tangent of 5/12, 5 divided by 12, and 22.6 degrees. I think I estimated that it would be bigger than 20, and then I used the protractor, and the protractor said about 23, 24, so pretty close. Theta, that is an ugly theta, by the way, is approximately 22.6 degrees. Angles are measured in degrees, so make sure you write. This is like the label. Make sure you label your answer absolutely. If it doesn't have that, by the way, it means something completely different, which you'll find out next week or the week after that. Also, I said if you accidentally have the fraction upside down, you're going to get an unreasonable answer. Let me show you how unreasonable your answer is. 67 degrees. Does that look like 67 degrees? Of course not. No. This one is. So if you actually do it upside down, accidentally do it upside down, it might be telling you the measure of the other angle. So be careful. Make sure your fraction is properly written. And next video, I will talk about these two problems. YouTube won't let me upload a video longer than 10 minutes for some reason, so I have to do it in 2 parts. Make sure you watch the second part. Yeah.